Yeah, and we are live. Cool. I think let's do a minute. The people show up. Um, as I make sure my stream's working and everything. Then I'm gonna dive right into this. Right into this. Right here. Just got the live email. Still gonna confirm the video is running to this. Right here. Right now. Okay, cool. Video's running. Everyone's here. Let's do this. What do I want to do today? So I want to do quick and simple, a rather quick stream today. What I want to do is DevHeads, which is a group I'm on. Um, DevHeads IT sub DevHeads. This one, yeah, DevHeads.io. Oh, why is that? Why is that like that? Okay, cool. Damn. So I'm in a group. It's a DevHeads IoT server. I'm on this group, which is a Discord server. Well, yeah, perfect. I'm on this group, which is a Discord server, and you can. It's gonna be an invite. I'm already in. There's your invite if you want one. Please join us. So it's a group where there's lots of developers there, lots of industry integrators, lots of industry players in the server, and most of the time we're talking about what we're working on and doing educational content to help each other go through stuff. So this group has a program called IoT Kit Reviews, where you can request a board or evaluation sensor or whatever, and they can send it to you, and you get to review it. So that's what I'm going to do today. So DevHeads managed to send me this MIMXRT1060-EVK board. And what I'm going to do today is I'm going to try and run us through what this board does, what it is, and what we can do with it. And then I'll lay out a project plan over the next few that we're going to be doing over the next few weeks to just kind of explore the features of this board and also look into building um, examples that are very close to real world applications. Okay, cool. So let's look at this board. This board is the best way I can. It's from NXP themselves. They call this a low cost, low cost, easy entry, entry level board for prototyping before you commit to the onboard processor, which is the MIMXRT 1060, I think we can call it that. Well, IMX IMX RT 1060 crossover MCU. So for industrial and commercial applications or consumer applications, that's kind of what I'm saying. In particular, this board that I have is the one that is for industrial applications. So I'll quickly run you through the features of this board, just speaking through, and then we'll we'll kind of do a bit of a board bring up using Zephyr and get a little firmware application going. And then once we have the firmware application going, we'll describe what project we want to build with this. Perfect. So this board comes with DRAM of something like 256 megabits, and all of this stuff is here. So you have 256 onboard SDRAM memory, 64 megabit QSPI flash, which is this little if I'm on, which is this little guy here, I believe. And then we have a hyper flash, which is here, 512 megabit hyper flash. We have a socket for the SDIO card. We have on the back here, we have an LCD parallel connector. And then on the side here, you'll see we have, what's this? This is a touch connector for whatever LCD module you use. Cool. And then on the front, or on the top of the board, we have two USBs here. I believe this is USB on the go, and then this is USB host. And then let's see. We have an Ethernet PHY or physical connection on board, which is really exciting because my humble STM32 comes with an Ethernet controller, but it doesn't come with a physical connector. So this is cool for prototyping Ethernet applications really quickly. And then, okay, cool. What's the next thing? So we do have a couple of audio sensors. We have an onboard audio sensor somewhere here. It's going to be in this area. It's going to be a MEMS kind of sensor. And then we have a microphone connector jack over here. Cool. I hope I'm showing this right. And then what else? Let's look at a few things. The processor that we are actually programming, this MIMXRT1060-EVK, is here. This is the guy. And then you have another NXP processor here that's going to act as our debugger. I didn't check out which one it is. I didn't check out which one it is. And then we do have an SW7 bank of switches here. This bank is kind of the boot switches. You'll need to mess with these if you want to define, or rather decide whether you want to boot from Hyperflash or QSPI, or you want to boot straight from the ROM, or you want to boot from UART. So you need some specific configurations on this switch in order to get that. We have a reset button on top here. Okay, cool. We have a user button. I believe this is a user button. And then we have a power button here, and then our power on reset button. And we have a power switch here that works with this 5 volt DC jack. And what else? What else? There's a JTAG programmer debugger serial wire debugger 20-pin connector here. And then this little NXP MCU comes with all the connections, so that we have open SDA with DAP-Link, and that's what we're going to be using for programming right now. And this is actually one of the contentious issues when you're wanting to run Zephyr on this board. So it's quite easy for all the how do I say it? For the online documentation to say you need a JTAG debugger in order to run Zephyr, or you need to do the USB DFU mode and then drag and drop in your bin to run Zephyr. But I'll show you how to run Zephyr straight from a West on this board. And then of course we have what is it? An IMU sensor here, which is the six-axis how do you call it? Six-axis accelerometer. And then along with this, the MIMXRT1060-EVK comes with I know it offhand, but I'm not gonna. I'm gonna with a CMOS sensor, which is MT9. I'm going to just confirm. MT9M114 camera. So this sensor, this CMOS camera sensor. This CMOS camera sensor comes with the board, and we're going to prototype with it. And this camera sensor goes to this connector over here. So it's going to be one of the things that we use for prototyping. Cool. So what's this board for? This board comes with around 600 megahertz of That's the max speed you can run with, and 1024 KB on-chip memory. This would be an ideal board for sort of like, if you want to do, let's think about it. If you want to do, say, you want to do, how can I explain it? You want to do, say, industrial automation. You want, say, you're controlling a conveyor belt and you need to collect data along the conveyor belt, and you have several sensors along that belt and you want to collect data from that. This is a good board for that. Automotive applications, that's kind of what we're going to try today. Try and design a project around an automotive application. Since this board comes with an onboard CAN bus controller and a CAN bus transceiver, and which makes this board a CAN bus node, it's very easy to do CAN applications on this, because usually you have a board like the STM32F4 and it comes with a CAN controller. But on a board like that, you'll need a CAN transceiver to actually use CAN. So the MIM comes with an onboard CAN transceiver, which makes it a node, and you can easily prototype CAN bus applications with that, which is kind of going to be the focus of our demo application later as we go along with this series. Okay. What else can you do with this board? I would say, yeah, although it's and crossover MCU for industrial applications, you can still build consumer applications on this. Say a control hub for your smart home, or let me think about it. Like, you could also build a hub for your home security system, if that's what you're calling it, somewhere to control all the thermostats and all the doors and access control. The processor on board, the 1060, can be used for wearable devices. I mean, you don't need all the sensors and all the stuff that comes with the board. You don't want to necessarily wear this as a watch. So you could minimize this board and come up with an application that could work for that. And then I wanted to look at these interfaces that are on board, on chip. The on chip interfaces mean we can now use this chip without needing to add more stuff. So we've got the usuals, which is NVIC for ARM. This is based on ARM Cortex M7. And then we've got SysTick, as usual, the hardware timer. And we've got display, how would I say it? A parallel display connector. We've got flash, we've got GPIO, which is usual. We've got SPI, we've got I2C, Watchdog, which is good for ARM stuff. And then we have SDHC4, which usually I think in others is called SDIO, or it could be a variation of the SD drivers or protocol. We've got UART, we've got Ethernet, we've got USB on the chip, you've got CAN on chip, you've got DMA on chip, ADC, SAI for audio, and Flex SPI, Flex CAN, I believe, because this board supports both Flex CAN, which is classic CAN, and CAN FD, which is CAN with a variable data rate. Okay, cool, amazing. So that's the board. Whenever you do bring up this board out of the box, it's going to have the factory firmware on it, and I think it's going to be a blink at a certain rate. I'm not going to cover how to do this on this stream, because that's covered. Number one, that is covered online, and it's just plugging in the thing. And if you want to see how you can do that you can just pull up the evaluation kit page for this board. And if you go to documentation, I think it was getting started. Yeah, getting started. If you go to getting started, there's a video link and it will show you how to get started with UART and that. What I do want to cover today is this part of the the undocumented supported by Zephyr OS part. So you can, if you want to use MCU Expressor, you can use that. You can if you want to use arbitrary ARM, GNU tools, you can do that. But what I want to cover today is this undocumented supported by Zephyr OS part. Okay, cool. So we've seen the board. We know what the board is. We know what to initially run it with the factory firmware that comes from, which basically comes to a point of like unplug unbox the evaluation board, connect it to your computer over USB to the programming port, not to this OTG or host. Once you connect to that, you'll get a blinking. The one that's running right now is the Zephyr blink, but you will still get a blink from MCU Espresso. And once you install the IDE and you can start running, there's enough example applications and you can run them through the IDE. So, but today we're covering through Zephyr. Okay, cool. What do we need to do to set up this board so that it can run on Zephyr? If you do follow this documentation, configuring and debug, programming and debugging. So I'm on Mac, but you can easily do this on whatever environment you're on. It's quite easy to think that you need to use JLink or Link server, but because PyOCD looks like it's not supported. But since West chiefly uses PyOCD, we're going to focus on that. So what is the first thing you need to do? You're going to need to unplug the board. I'll do it now. Unplug the board, press and hold the reset button and connect it. Once you connect it, after a few seconds, you can let go. If I'm right, there's a steady blinking light in front of me, a steady light on in front of me. What this does is it puts the board in Kims's DAP-Link update mode. Let me show you. So if we go to my file browser, we will see this. This is what we will see. Maintenance. Once you have this maintenance USB device, what you need to do is go and here. You need to go and download the latest debug probe firmware. Yeah. You can get it from this link. So debug, yeah, here. So yes, default firmware, something like that. Exactly. So you need to come here and you need to download one of these firmwares. Okay. So you need to download the latest one. I already have the latest one. So it's something like one of this. It's going to be choose your board to start MIMXRT1060-EVK. And then you need to download the latest one of this. I already have this one, DAP-Link. And as this describes, you're in maintenance mode, you download one of this, and all you need to do is start your board in bootloader mode, keeping the reset button pressed while connecting the USB cable, release it, and then you copy this binary that you've downloaded here, And what you need to do is just drag and drop that binary into this device over here. I've done that already. I think if we go to my downloads, we will see, let me see by date added maybe. Yeah, yesterday. We'll see I did download, well, maybe it's on my desktop, but date added. I did, yeah, there you go. LPC 422. That's the bin you'll get. Once you get that bin, you can drag and drop it into the board. I've already done this, so I'm already updated. Okay, the next part is to, once you've done that, it will reset itself. And then you need to do a power cycle. So you do that, and then you connect it again. And that's a power cycle. And I expect now we wouldn't get the same results. It's a blinking light. And I think we'll have a blinky going, if I'm not wrong. We should have blinky going somewhere. Where's the reset button? Regardless, we'll get blinky going just now. So what happens now? We get, once we reconnect back, we get the R1060-EVK. Okay, cool. So we're back to normal operation. That's the first step. This is a key step. It might be confusing to float through all of this. It was a bit for me, as you can see, with all the click links. But once you get that, it's going to be good. So step one, update the firmware, update the KIMSYS DAP firmware. Step two, you need to make sure that this little SW7 over here is set to, I believe it's 1100. So 1100 means the first two are on, the first two switches are on, the first two dip switches are on, and then the second two dip switches are on off. This puts it in, let me look at the hardware user guide so that we can see. So the hardware user guide describes boot modes. Yeah, and these are not all of them, typical boot modes. There's more. Yeah, so the reference manual has more of them. But the one we have right now is basically boot from, use the UART to bring in firmware and boot from that, and boot from the MCU from the updated firmware. Okay, cool. So that's the first step you need to do. And the second step is to modify that. The third step is, by default, Zephyr wants to use J-Link. Okay, so this is the default one, J-Link debug host tools. So by default, Zephyr wants to use the J-Link and which works with the JTAG to program the board over SWD. That's what the default setting is. Okay. Now we want to change that default setting so that we can actually end up using KIMSYS DAP. The way we do that is in Zephyr's code. We're going to want to cd, I think it was user. Yeah, we want to go here. So go into Zephyr, your installation project of Zephyr. Then you need to go into Zephyr, the directory is Zephyr in there. Then you need to boards, and then you need to go to NXP, then MIMXRT1060-EVK. Once you're in that, if we look in here, we have, and I'll just try and zoom in so we can see. Once we have that, we have this, which is a board CMake, board.cmake. Where is it? This is fine. So what we want to do is we want to modify that. Cut. Okay, actually, get diff. Okay, ls. Okay, this is get diff board CMake. Yeah, that's fine. So these are the changes you want to do if to the existing board CMake. So you'll need to remove all the J-Link options. So remove that J-Link options. Comment out the J-Link option 1 and the other option for that for J-Link, and basically remove all the settings that are setting it up to use J-Link. Then enable this setting here that so that it runs using OpenSDA. Okay, and also at the bottom, remember to remove the J-Link setting for in the CMake. With that, you have the board set up and ready for Zephyr. So 3 steps that we outlined. The first one, update the KIMSYS DAP firmware, and you do that by going on the the Zephyr page for this board, and then on that page you will find this link. There was a link here for updating. Yeah, I believe it was this one. Yeah, and then you'll have to go here, and then where was it? Where was it? Where was it? Where was it? Yeah, yeah. Go to this link, OpenSDA. Okay, cool. Update the thing. Step number 2, on the board itself, switch this SW7 over here should be switched to 1100. Okay. Now, here, once you've done that, update the Zephyr CMake in the Zephyr installation directory on your machine. And then once we have that, now we can go and compile the normal Zephyr. Okay, cool. So this is just the normal Zephyr Blinky. Okay, cool. That just to confirm that as you can see, there's nothing blinking. The user LED is not blinking. There's just a power LED up here, I believe, down here. Power LED. And then there's no other LED blinking. So let's flash that. So let's do source, okay, west flash. Okay, west build, west. You see, so I'm gonna build Blinky for the MIMXRT, and I'm gonna do a pristine build. Let's do a pristine build, which is a clean build from scratch using Zephyr. Amazing. We did a build. West flash. Okay, cool. So now, as you can see, I don't know if you can see, I don't know if my open OCD shows that low. Yeah, what I need to do is enter the number. So I need to enter the number of my, yeah, I need to enter the number of my probe so that I can use it. Okay, if I press O, I'll go here, press O, put in, it's gonna flash it. And then on my board, we should have seen a red for starting, and then soon we should get a blinky going. Okay. Just making sure. Okay. Running it again. I think my switches are wrong. Okay, cool. So that should fix it, I think now. My switch was wrong. Isn't it lovely when your live demo decides not to work? 1100, yeah. And then do I need to reset it? Do I need to disconnect and connect back? Power on, power off. Might have done something wrong. It's not a problem. It's not a problem. Demo goes, as usual. Okay. I'm gonna try one more change. That's not a problem. Just one moment, please. Still, we have a fail. Yeah, 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 yeah. As you can tell, this happens quite a lot. 0010. Okay, let's try that. Let's try 00100. I'm going to try that again now. I know what I've done wrong. So I've managed to change 001. It's going to be my dip switches. And I've broken it. I'm going to try and reflash the firmware. Reflash the I'm going to try and reflash the reflash V. Keeps his depth somewhere. Let's try that. It's not a problem. MIMXRT1060. Okay. And I'm going to download binary. It's already on, but it's fine. Yeah, actually, why not? Why not put it all where it's supposed to be? The same. Okay. So yeah, it's the same thing I had. So I'm gonna take this and I'm going to drop it into maintenance. It's gonna disconnect itself. It's going to appear again. RT1060. Perfect. Okay. Okay, so I've unplugged it now. We've updated the thing. I wonder if that's actually what makes it break. You probably cannot go into update mode without doing an update. Let's flash 0. Okay, cool. So that is kind of how. Should I stop this or should I just keep going until I'm wondering? Should I stop or should I keep going until it runs? I want to keep going until it runs, but I know it's a simple problem that I've introduced. Let's open the reference manual. Is this a reference manual? A reference manual. Let's do boot. Boot modes. Boot modes, yeah. So we want to do boot modes is let's look at 01 0011. I'm going to try this mode until Okay, let's see. Let's see. Someone on the forum is advising to try and use just drag and drop. Let's see. Let's see if drag and drop works for us today. And then even if it doesn't work, then I'll have to explain my project and then go back to fixing this later, which is fine. We're used to this by now. I want to go to users. I want to go to Zacon. I want to go to Zephyr. I want to go to Zephyr. I want to go to samples. Basic. Blinky. Wants me to, okay, build. Try that again. I will fix this. I always fix it. Okay, cool. So let's try this. Let's see if this works, and if it doesn't, it's fine. It's okay. So do I get a serial probe or anything of the sort? What do I want to see? Okay, nothing. So I'm making some sort of blunder in all of my work, and I'm not getting a blink. This is okay. We can fix the blink. It's okay. It's fine. And in the documentation, it will all be there. So what's my project plan with this thing? So what I want to build with this thing is I want to use it as a small automotive system. I want to use this as a pretend body control module, BCM or computer, and Basically, what I want to do is receive a CAN message on this from a transmission control unit or from another MCU that is pretending to be a transmission control unit. And from that MCU, once I do receive a CAN message on this board, what I want to do, or on this processor, what I want to do is set up the set up the display, set up a display driver using this screen, which is it'll all be in the documentation. It's a 240 by 320 screen, and show the feed from this camera on this screen through this board. So what is that simulating? What I'm basically simulating is I want to simulate uh, a user putting the vehicle into reverse mode. And once you put the vehicle into reverse, I want the board to react by um, changing the heads-up display, or rather the display of the infotainment unit in the car, to display the camera feed from the rear of the vehicle, which is how modern vehicles operate. And what I'm going to do is I'm going to use the STM32F4 as my transmission control unit, and that's the one that's going to be beaming out the CAN message. So we'll have a an MCU being a CAN a transmission control unit, another MCU being a body control module, BCM. Whenever the transmission control system broadcasts a CAN message saying, "Hey, I've gone into reverse," this CAN message is going to make the body control unit go like, "Hey, we are going into reverse, and what is happening is I need to, since we're going into reverse, I need to switch the infotainment screen to display the camera feed from the back so that the user can reverse the vehicle." Okay. And all of this, it'll take a few, because we have to implement we have to implement bare metal CAN messages from the STM32M4 F4. And then we'll have to implement CAN using Zephyr on this board. And it will be interesting to see. I can do a demo where we just send out CAN messages to Logic Analyzer and see them. But I think it would be nice to see CAN messages coming through to the board and it reacting in a way that a board in industry would react to it. Sorry. So my demo didn't work today. That's fine. I don't know why, but I was ready. I had all the code ready, and I have a feeling once I do disconnect, it'll be something really small that I need to change, and that's gonna make everything work. So I'll I'll look at it. I'll see what needs to be fixed, and then once we have that, I'll I'll come back, or I'll do it in my writing and show what needs to be changed. It's probably going to be something really simple, to be honest. Uh, let's try one West Flash. What? What did I? What did I? Oh, Which blink is this I'm running? I'm sorry, I could be CD. Which blink is this? Okay, good. Yeah, that's okay. Okay, cool. So let me sit down, debug this, and then I'll post on why it failed. And as usual, we'll go on from there. Thank you so much for coming today. It's amazing. And I will definitely have to revisit why the firmware isn't running. I expected something small that I fixed, I've done wrong. Let me find this. It's just live demo codes. Sometimes you can never manage to demo live what you did. Thank you for attending today. I will post an update on my YouTube, a text update when I have a solution for this. It should be later, it should be in an hour or so, and then we can go on from there. Thank you so much for attending my stream today, and leave any comments and likes. Remember, if you want to support me in doing more streams like this, um, suggesting things that I could do, and likes and comments really help keeping me going. Thank you so much.